Right now, we want to talk about VaporLock. We've got Anthony Scheller and George Gomez. Anthony, you're head of security engineering with StubHub, and George, you're with Twilio. What is your role with Twilio?
I'm a security engineer at Twilio.
Perfect. Excellent. Folks, if you have any questions for the fellas, as we go through, as they're talking, go ahead and drop it into Slido. I trust now on the second day, you folks have already gotten pretty accustomed to the app. You've got the website up and running. If not, just go over to BSidesSF.org/QNA. That's Q, N as in Nancy, A. And you can drop your question in there. If we've got time, we'll have the fellas answer it. I'll ask the question on your behalf. And then following this, we'll get you folks on to the next session. But more importantly, get you on to lunch. So with that, fellas, why don't you take it away for us?
Cool. Hello? Okay. All right. Well, yeah, and so this is VaporLock, but it was formerly known as AiM. So you guys are in the right place if you came for AiM. So yeah, today we'll be discussing about how we've leveraged large language models and control plane log analysis to address the principal of least privilege problem with service-to-service identity and access management policy creation. So going over the agenda, so we'll start out with some quick introductions, and then we'll move to an identity and access management recap, what it is and why it's important. From there, we'll start talking about how we go about navigating the challenges of governing identity and access management at scale. From there, we'll talk about the cloud security maturity progression in large enterprises and what that looks like. And that'll kind of lead us into VaporLock, talking about what it is, how it works, its architecture, followed by a quick demo. And then we'll go into some improvements and Q&A. So a little bit about me. So my name is Anthony Scheller. I've been in some form of security engineering for a little over a decade now. Started off my career in offensive security testing, doing consulting at PwC. From there, I went over to Hulu and built out the cloud and network security engineering function over there. And then more recently worked with George over here at Twilio as a staff engineer on the cloud security team. And I'm currently leading security engineering over at StubHub. And so now I'll pass it over to my colleague George for his intro and get into the meat of why we're here.
Great, thank you. So good afternoon. My name is Jorge Gomez. I'm a staff security engineer and tech lead in Twilio's cloud security engineering department. I've actually operated as a security engineer or architect for the last 15 years, primarily in different industries, but primarily in the energy, tech, and cloud infrastructure. I actually met Tony about a year ago, and we used to have really interesting conversations about how overly complex IAM policies can be, specifically in service cloud providers like AWS and GCP. I actually recall performing an audit on a production account, and I saw an IAM policy where they had star for action, star for permission, for actions, permissions, resources. And I questioned the lead engineer about it, and he simply said it was just easier to get done this way, and he just couldn't figure it out any other way. So it's no wonder why misconfiguration still remained the top vector for data breaches in cloud service providers. And these complexities really are the reason why we've seen a lot of those high profile data breaches like Home Depot, Deloitte, eBay, et cetera. So Tony and I actually brainstormed different ideas on how we can solve this problem and really make it easier for engineers to create their own IAM policies following that whole principle of least privilege, right? And this is really how we built VaporLock. So before we just jump into solutioning, let's take a step back, look at some of the challenges behind IAM policies, and let's start by just defining what IAM is. So IAM, Identity and Access Management, really focuses on three core areas: authentication, authorization, and auditing. So authentication really deals with that identity, that principle, trying to validate that they are who they say they are, right? Authorization checks permissions for that principle to ensure that they have the right access, the right permission sets, right? And then auditing just keeps track of those events to ensure data integrity. Now, if we start focusing on IAM policies in particular, it really just creates that, creates that ledger, that description of what that resource or identity should have permissions to do. And in simplest terms, it really describes the who can access the what. So complexity really starts to arises where you start to add multiple permissions along with the growing number of available services in AWS and GCP. And then you start adding the conditional statements that you can add for each one of those. And then you're also trying to meet compliance requirements to restrict blast radius, right? And then you end up with a lot of permutations, a lot of combinations of different permission sets that you could apply on any given resource, right? So it does leave a lot of room for error here. So certain strategies to kind of help with this really falls under two camps, right? Centralized and democratized. From a centralized approach, really there's a few teams and usually just one that is responsible for reviewing and approving these policies to ensure principle of least privilege is being followed, right? Generally, this burden falls on like the security team, but we've also seen platform engineering teams take on this action. It really just depends on the industry. General tools that they use to help simplify this ends up being things like using Terraform or some infrastructure as code module, but ultimately you still have that single point of failure because you have that central team that has to review this and ensure it, right? On the plus side, you do have standardization, right? So there's a benefit of having a standardized process and approach when it comes to that, but it's at the expense of developer velocity. Now, the second strategy is democratized. And in this approach, engineers are empowered to build their own services and really to own their own services, and which should include AiIM policies. But with this model, it does increase developer velocity, but it does require that discipline from teams to ensure that they're following the principle of least privilege. And general strategies here involve creating permission boundaries or reusable infrastructure as code modules. The problem here is that not all engineering teams are created equal, right? You may have some strong engineering teams with really strong security practices, but then you have weaker teams that may not have that same maturity, right? So from a security baseline perspective, it's just not consistent, right? So you don't have that standardization. And it also requires that constant care too, right? With the ever-changing landscape with new services being offered by the different CSP providers, right? I wonder, Tony, in your experience as a consultant, what would you say organizations typically adopt?
Yeah, so in my experience, right, without fail, organizations who are poised for expansion and always looking to move, they really tend to move towards a democratized approach, right? And so let's take a look at why that is, right? So organizations that are scaling, they're hiring more teams to build more features quickly, right? And unless you're scaling those, core platform and security teams at the same rate as your developer teams, centralized, the centralized IAM governance and infra governance just won't work. And as we know, that's pretty much the case. Security practitioners, right? As security practitioners, right, we really need to architect the way that we, deploy our controls in a way that covers this decentralized model. And so with that said, right, organizations with a mature cloud security posture and have generally implemented like these below processes and technologies to do just this. So we started like the foundations, right? So infrastructure as code pipelines. So that's moving, that's the principle of like moving all of your infrastructure management and creation and modification, right, through infrastructure as code pipelines and putting it all into code, right? And so there's a couple different benefits from a security perspective, right? One of which is you have like repeatable, maintainable infrastructure. It's all checked into your version control system. And then, right, this also allows for, security teams to kind of embed those security by default controls into those, IAC reusable templates. And so once you do that, though, you can then start, that kind of paves the way, right, for teams to start, security teams, right, to start implementing the policy as code checks, right? So if you're using Terraform, it's things like, HashiCorp Sentinel or CF Guard, ConfTest, OPA. And so from there, that allows, security teams to, to check that infrastructure as it's moving through these infrastructure deployment pipelines, does it meet certain criteria? So an example of this is like, let's say you have an, AiIM role module, right? And this is an example in Terraform. You have an AiIM role module and you put in some explicit permission boundaries and some explicit denies, but you still want developers to be able to create their own identity and access management policies. You can still like put that through the infrastructure as code pipeline, have a policy as code check that says, hey, you might not care as much and still do a review, but you might not care as much as long as they're using this specific infrastructure as code or Terraform module. And so using, kind of building on different layers, right, allows security teams to do that. And so next item here, right, is organization or tenant layer IAM protection. So this is, most commonly kind of like aligned to, AWS's service control policy module or model, where basically you have these, at the tenant level or organization level, you can define certain, deny policies, for example, and say like, no matter what permissions that, different principals have in these child accounts, right, you still can't do X, whatever that may be. And so, security teams, going further through the list, right? Security teams will also do, routine permission audits with, cloud service provider control plane analysis, and then developer education, right? So as we know in this decentralized model, where you're moving infrastructure management and creation out to the developers, right? Having them understand the gravity of the configurations in the infrastructure that they're creating and making sure it's, secure is critical. And so, and lastly, right, SaaS cloud security tooling. So that's like your Wiz, your Orca, your Prisma Cloud, all of your other ones of flavors, right? Using those as like cloud security posture management tools. So looking through your environment. Do I have an externally exposed S3 bucket? Do I have an EC2 instance that has security group up into the world, right? Really good at checking those things. And so they've also added additional functionality, like the whole industry really in the space has added additional functionality that kind of looks at identities, right? So IAM permissions that are overly permissive based off of what the principal has been, using in the last couple months, and even IAM roles and policies that haven't been used in general.
So, Tony, I have a question. So it sounds like some SaaS cloud security tools like CSPMs are actually doing stuff like this, looking at overly permissive IAM policy. So why do we need VaporLock?
Yeah, great question. You should use these SaaS products, right? If you can afford them and you can integrate them into an environment, and it's great for that reactive approach, right? So after the principals, have already been deployed, after the infrastructure is already working and leveraging those, those roles and IAM users, hopefully not the users, but that really, it helps out a lot with that reactive approach, right? But we feel that there's one opportunity, right, that is not being taken advantage of, and this is the shift left approach, right, when it comes to allowing developers to create better IAM policies to begin with. So that's kind of like how VaporLock kind of came about, right? Is that we're looking at why not, like, there's a lot of good reactive approaches out there, right? Like, with your SaaS security models and even manual like reviews of, your CloudTrail logs and other like control plane logs. Why don't we, provide something that allows, developers in a self-service manner to actually generate better policies before deployment.
This is more of a complementing a CSPM, right, rather than a replacement. Would you say that?
Exactly.
Gotcha,
Exactly. Let's take a look at VaporLock. So what is it, right? So VaporLock is it's a standalone open source project that you can deploy, via Helm on your Kubernetes cluster or your favorite container orchestration platform using Docker Compose. And you can expose this service, right, the UI and the API to developers in order to generate new and right-size existing IAM policies based off of natural language descriptors. And we'll get into why this is important later on. But like I mentioned, some of the core features, right? It's a self-service platform, right? So enabling the developer to get, to keep in the driver's seat, right, as they're creating their infrastructure. And for platform engineers, right, they can use the API to integrate these processes into their CI pipelines. It allows for that net new policy generation, right? So that's the proactive approach that we're kind of after. And this leverages, the large language model, permission generation workflow. And then, right, we still keep the policy right sizing, which is the reactive approach, right? It's still very important. And so there's also no magic bullet, right, when it comes to generating policies to begin with, unless you're looking exactly at all the documentation, which we know is not always the case. And so, then from there, as we're returning these IAM policies, right, you can choose different formats, right? So JSON is one of them. It's the main default one. We also support HCL and Terraform. And then if you want to take a little bit more AWS-centric approach, we also return these policies in CloudFormation templates. And so, kind of the last item here, right, as we were building it, we wanted to make sure that it was extensible in the way to, like, as we're getting community involvement and stuff like that, to really be able to, with relatively low level of effort, right, be able to extend this and add additional services, if you will, to this IAM service catalog. And as we know, right, good technology, won't be adopted unless it's easy to use. So I'll go ahead and hand it over to George, and he'll tell you how to use it.
Yeah, and that's a really good point, Tony, right? So it's really important that we make a solution that's extremely developer friendly. And the way we approached this was to create a cloud-native solution that has both a front end and a back end. The front end is written in Next.js, really easy to use. As you see here, the dashboard just has 2 services right now that we've exposed. But the idea is that this dashboard would become like a service catalog of different IAM services that you could provide to help you with IAM in general, whether it's resizing the policy or creating a brand new one from scratch. Now, if you click into that first one, that create policy, you end up with this web form here, right? So really easy to use web form. You're providing a policy name. You're going to select the AWS service that you need, the source service. That's from a dropdown of available services. And then you're also presented with the destination services as well. You're going to provide a dropdown. You can add as many as you need, right? And you could select the permissions that you need as well. And those are easy, really understandable natural language permissions. Read, describe, write, admin, it's just a little bit obvious. So it determines behind the scenes what permissions you're actually going to need. You can add as many as you need with the plus button there that you see on that left side. And or you can actually even toggle the Amazon resource name to provide an actual ARN to be a little bit more precise and hone in on your exact AWS resource. From there, you just hit the generate policy button. It's the blue one there. Can't miss it. And then it makes calls to OpenAI, starts creating that least privileged policy based off of the parameters that you've provided. By default, it's going to provide this in JSON, right? So you can grab that JSON, copy it, and apply it to your AWS resource. You can also, we also support Terraform, right? We're big fans of infrastructure as code, so we have support for Terraform. So I'll put the Terraform style, so you can use that and apply it to Terraform Cloud if you're using that. Or if you prefer something a little bit more AWS native, we also support CloudFormation. Now, the other form is a little bit simpler. Just you're only providing an Amazon resource name, just the ARN only, and you're going to hit the Generate Policy button. In doing so, it's going to start to query Access Analyzer and actually look at CloudTrail logs for the last 90 days and see what permissions that actual resource has actually used and the ones that it hasn't. As it starts to identify those permissions that it hasn't used, it starts to eliminate those and remove those. So it gets stripped away. So what gets returned actually ends up being those permissions that have been effectively used, following that principle of least privilege that we're all after. From there, you can just copy that JSON policy, apply it to your AWS resource, and like before, we support Terraform and CloudFormation. Now, like I said before, we wanted something that was really developer friendly, so we do have a front end that you saw there. So for those engineers that feel more comfortable with that front end, they can use the form, really easy to use. We've made it as dummy proof as possible. But if you're a little bit more of an advanced engineer, you want to use APIs, you want to do something more programmatic, using CI, for example, we do offer the APIs, and it's all through a Swagger doc. So what you're looking at here is the first endpoint, the create policy, and this aligns to that first form that you saw. So the schema is really simple. You're providing that source AWS service, the destination AWS service, or the ARN, depending on your need, and then the actions that you need. From there, you indicate the output format, and then you just hit submit. It's a post request. What gets returned should be an AiIM policy within the format that you requested, that JSON, that Terraform, that CloudFormation. And that's pretty much it on that specific endpoint. We also have the other endpoint for request right size permissions now. Even simpler, just ARN and the output format. But instead of actually getting the AiIM policy here, it's actually returning the request ID. So like I mentioned before, we're making calls to CloudTrail, right? We're looking at the last 90 days to see what permissions were effectively used. So that process can take somewhere between 30 seconds to a couple minutes, depending on how large those logs are. So you get that request ID. That request ID you can use for that third endpoint, which is the get resize permission. So you start to query it and then see if that job is complete, and then get returned the actual AiIM policy in the format that you specified. So let's look at the front end and the back end, but let's actually dig a little deeper on the architecture and the sequence diagram, and I'll let Tony speak to that.
Awesome, thank you. VaporLock is comprised of a couple of different components, right? So if you look at the top here, you'll see VaporLock. That is the front end, the Next.js front end, and API router. And then from there, we have the VaporLock backend API that's really used to kind of orchestrate the respective processes that are going on in the backend. And then from there, this third component is because of the asynchronous jobs that we're actually needing to conduct during some of these processes, we're using Celery in the backend with a worker node, and then a Redis cache for kind of like a state manager backend. And so if we look at the top flow here, right, under the create policy, this is like the generating right size policies using large language models. And so as a client, right, you can see all the way on the top left, if you're using the UI, right, you'll make a GET request directly to the front end. Else you'll just use the schema that George was talking about earlier. You'll make a POST request directly to the API. But what we're doing under the hood is, right, once we get those parameters that you've sent us, we're going to interpolate a prompt that we're going to send over to OpenAI. From there, we're going to get back a generated identity and access management policy. And from because, right, we wanted to ensure that we take care of some of the cleaning in regards to some of the shortcomings of large language models, specifically around hallucinations. Right, we're actually taking that AiIM policy document and we're sending it over to AWS AiIM Access Analyzer to check to see if those permissions are indeed valid. And if they're not, we actually, when we get it back, we actually scrub those particular actions out of the policy. We do some additional processing, put it in the format that you desire, and then we send that back to the client. So if you look at the second part here, which is the resizing flow, this is the more deterministic way, right, of creating a principle of least privilege policy. Same principle applies as far as depending on how you're accessing VaporLock, whether it's through the UI or the VaporLock API directly. From there, though, it gets interesting because then we take that principal ARN and we send it to our Celery worker node. That worker node is basically, it registers the job. Once it registers the job, we create a unique identifier for that job. We send it back to the client, so that way you can continue polling on that third API that George was talking about. The front end, we do take care of that for you. For better user experience. And then, so as that worker node is, made the request to IAM Access Analyzer to generate that new, IAM policy via the CloudTrail log analysis, right? Once it's done, it will actually put that policy into Redis. And so as that polling is going on, right, the VaporLock API is actually going to reach back into the Redis backend, grab that IAM policy, put it back into the format that you want it, and then send it back to the client. So there's a lot to go through. I'm sure we'll get some questions. But now let's take a look at the demo. So this is basically everything George showed you earlier. And we will, we'll go over here. And talk through it. This is the homepage right now. So you have the create policy and let's go back a little bit. You have the create policy and resize policy. So in this particular first part of the demo, we're going to go to the create policy section. So this is using that large language model workflow that we have. From there, right, you're presented with that same form that George presented. You put in all the information you want, right, such as your favorite policy name, the source service, right? So in this case, Lambda, EC2, what have you, anything that can have a principal really. And then using those natural language descriptors, right? You can, pick what you want. In this case, I believe it's list and subscribe. You can add in, I think we're going to do it against the SNS topic. And in this particular case, right, if you notice right underneath, you'll see the ARN toggle. And so if you don't supply a ARN, right, we're just going to use the service name. And then on the right-hand side, you'll see in a second, we're actually putting in a ARN placeholder. So that way you could put your ARN back in for you, like if you don't want to provide it. If you do provide it, we'll actually extrapolate the service names from that and then, conduct the same processes. So you can see that here. So this is in JSON. You can see an output here going into Terraform. And then same thing going through the CloudFormation templates. So this is a return of the YAML file. So after that, we'll go to the back home. We'll go to the resize policy section. And this is right providing that, that simple principal ARN. I know I'm going to get a question about it. That AWS account no longer exists, so don't get any ideas. So then we, the background process has occurred, and we have that policy returned directly from there. And then we also have the light and dark themed, which we thought was extremely critical for an MVP because, obvious reasons. And then here we have the Swagger docs, right, that were generated as a part of the Fast API framework that we're using for the backend. So we have all those schemas there. But yeah, that's the demo. And so then we'll move on from there. Oh, okay. And so some future improvements, right? So one of the things we already know that we kind of want to do and to make the effectiveness of the policy creation even better is start implementing reinforcement learning from human feedback. So what that's going to allow us to do is basically now we have that data right from the original prompt that was created by the application. We have the response from that the IAM policy that got returned to the user, and then once we get that reinforcement learning from human feedback, right, we can determine if it was good, not good, or indifferent depending on like the user feedback. So then we can start storing all that data, and then specifically on the OpenAI GPT 3.5 side of things, we can start fine tuning that model based off of that data. And so that's one of the things that we wanted to kind of get into. It's a little bit more on the data science side of things, but we think it's going to make it even better than it already is because it actually already works surprisingly. And so then we're going to add in some authentication authorization mechanisms. So you could deploy it, within your environment and hook it up to your favorite identity provider of choice. And then looking at adding additional models, right? So instead of using, GPT 3.5 Turbo, you can use a different model, right? Maybe one of the open source models and train it more specifically on like the IAM policy documents and all the documentation accordingly. Last bit here, right? This is really AWS specific, to begin with, but we want to start branching out as well and add support for GCP, Azure, and in Azure IAM policy rendering, as well as Kubernetes RBAC, and then some additional SaaS products.
And that's VaporLock. So I hope this was helpful to try to understand how you can use OpenAI and just LLMs in general to, solve security problems. In this case, and trying to right size your IAM policy and get close to that nirvana of least privilege that we're all after. So we'll open it up for questions now.
All right. We give a round of applause, folks. Fellas, we do actually have a couple questions here. The first one is, what is the benefit of using an LLM for policy generation and right sizing versus trying to do this using only deterministic methods?
Yeah, I think you want to take that. Sure. One thing to note is that for the right sizing portion is that we're actually using a deterministic method, right? So we're using IAM Access Analyzer to go through the CloudTrail logs and actually, really get the specific IAM actions that are being used by a given principal. For the LLM side of things, right? Our goal here, right, was, deterministic approach is, if there is a way, I'm sure there is, somebody will figure it out eventually, but considering, right, LLMs are available and ready for use, it seemed like a pretty decent way to start looking at, to going down that road as far as, generating new policies from just documentation. Of course, right, if you're, you want to do it super deterministically, right, you can just read the documentation. But as we know, that's difficult to do sometimes depending on your cloud service provider. And so it takes a lot of time. So this is kind of like that bridge into kind of going more that direction.
And I would say that, like, the idea with the whole dashboard, it's multiple services, right? So we're trying to provide a holistic, comprehensive strategy and how you address IAM in general, right? So we have the LLM models for that create policy, but then the deterministic approach with the right sizing, right? So we're trying to use benefits from both sides.
Thank you for that. There's also, you've got some props. One person is saying, great tool. What type of anonymization are you doing on the data before sending it to the LLM to create the policy?
Well, it's simple. We just don't send it, right? We're sending a fake one. We're actually sending a dummy version of the ARN, crafting it the same kind of format, same kind of resource, but not actually sending the actual ARN, the actual ARN in question.
Okay, and VaporLock is open source, you mentioned. Where can we find it? How can we contribute?
Yeah.
So it will be open sourced. We gotta do a few more adjustments before we let people look at the code. Just pretty it up a little bit, not to embarrass ourselves. But yeah, it will be available. We did put our LinkedIn's here. Is the deck going to be shared out?
Yeah, folks. For all of these sessions you're seeing in 12, 13, 14, and 15, about 2 to 4 weeks from now, the recordings will be out on our YouTube channel.
Okay. Well, yeah, we can supply because these are clickable links. So if you do have if you end up getting a copy of the deck, that you can just click on it. Else I'll figure out a way to get our LinkedIn's
Absolutely.
somewhere. So yeah.
Well, gentlemen, thank you for your service here. Anthony, some gifts here for care of Socket Security. Give Socket Security a shout out.